Welcome to another episode and video on my Arduino MegaADK with a breadboard with electronics and fischertechnik mechatronics, using chain with light dependent resistor, phototransistor, connected to this LED, then a motor which is activated by pressing this button with an RC circuit. Last time it just ran and I don't know why, but now it works as intended. You press the button and the motor works. And this combination of lens lamp and phototransistor that gives a certain, well, value of course, but this is an electronic switch, and finally an NTC which should be heated by the lens lamp. And the software that I wrote last time for it doesn't give a very conclusive value. Can be caused by the fact that the lens lamp is not powered by 9 volts but by the 5 volts that this Arduino gives. And of course that matters a lot for the intensity of the light, and of course it matters for the heat that this NTC resistor is receiving, and thus for the resistor that it has, the resistance. Anyway, the voltage is important. I can't do anything about that. What I can do is trying to get nice things working. And let's see, for this button, yes, that gives an immediate effect for the red LED. And this button gives an effect for this LED. And once again, this one is showing that the motor works. Now I should make this one work as well. Well, it works, but this is only visible now on the oscilloscope, which isn't really visible then. I could do it by means of a transistor, by means of an LED, and that's nicely enough. So those are two things, checking the code and checking on the NTC. So let's go to the code and see how things work out this time. Alright, so looking at how the transistor should give a visual element to its voltage whenever it is shown upon by the lens lamp, I'm looking at this LED, which is connected to pin 7, and then this is the code. So the only thing that is being done now is that there is a pulse modulated value written to the LED that keeps for 1 second, and then a much lower value is written. So this was, since it is the very first code in the whole code. This was the very first thing that I've written for this board, which means I can perfectly use it for something else, which is the phototransistor. So the only thing I have to do actually is make it an if there is any input value, make it burn now, or make it shine, whatever, put it on. Point is, which value does it give? So let's take a look at the phototransistor. This is 603 value, 607, whatever. And then I need something that I can use to block it. So let me grab a piece of paper, fold it, because last time that I did this, it turned out that it went right through the paper. So paper in between lamp and lens, and between lamp and transistor. This is not really what I expect. Is it even shown upon? Yeah. I can clearly see the lamp being mirrored in the paper. But the value isn't really impressive. So what I can do is, now here it is under 600. But what I can do anyway is saying, okay, if there is something on it, then make this LED blink. But that is only useful if there is a value, a real value difference between a yes or no thing in the phototransistor. So let's keep the border value at 600 in this case. So I am going to change this. So print, it is a 4 because that is the phototransistor. Now if, and then I have to take this part, is larger than 600, and I better put it between quotes. Then analog right, yeah, like this. And should I take a delay? I don't think so. Else if this is smaller than or equal to, no, yeah, smaller than or equal to 600, then do this. However, I have to see it, so want to see it and not just blink an eye and then it's gone. I want to really see it. Now, what is the influence of the lamp? The lamp is connected, of course, to other electronics, and that goes via pin 8. So what is the blinking frequency of the lamp? Through pin 8. Yes, that's a second. So then I better make this half a second. And then this can go. Alright. Now let's see how things work out in this way. And this is, of course, an LED, just like this. And just let's see how this will work out. First, is this correct? Yes, it is correct. Upload. Really? For what? Analog read? Okay, yeah. And this one has to have one too. And another one where I already did that. Else if, oh, this is too much. And this is one. Yeah. I need to wait. 1, 2, 1, 2. Yes. This is better. Go. Right. Right. So how are things going right now? It shines in one continuous thing, and that is because the phototransistor gives a huge value. So let's put a paper in between. Okay, apparently I should use something else, something thicker. Well, let's use a leaflet. And fold it again. So this is a discount leaflet. And let's do this. What does a transistor do? Oops, that is not the intention, obviously. But, oh, that's not good. Right now, the lens cap has come off the lamp, or the lamp cap more appropriately. Alright, once more. What value am I getting? Phototransistor 628. Now it's really blocking. Okay, then I remove it. Phototransistor. Are all the wires still connected? Yes, they are. And wires of the lamp are still connected, so that's no problem either. Then why are the values suddenly so high? That is something I do not get. First around 600 and now around whichever value up high. And removed, and it doesn't make sense to me. Alright, little paper again to check whether the lamp shines at all. Yep, it still shines. So how come the value has changed? Because now this doesn't make sense anymore. Another way I can check it, of course, is by means of this probe, which yeah, well, this should be this one. It's the blue probe, which is this line, and you can see that it is being shown upon. Now let me change the value of no, wait, I should use this one. So now you can see a real value change. So if I now put it in between, what happens? Really? Why is this happening? Why is it not keeping its value? Is the lamp that strong that it even shines through this thick leaflet? I doubt it. So why is it changing here? This is the input. Now this is the output from the transistor. It is the blue line on the oscilloscope. Right now with the lamp, yes, that can change, but right now covering it, that shouldn't be, or not as much. Alright, yeah, now I see something. Now it goes to one value and it drops. Then again, and now it rises also. So there is a difference, but not with this one, not with this LED. So what I better can do is check for this value. Around 630, 629 then, alright. So lower than 630. Let's see whatever happens now with the values. Nope. And this should be real time. Really. I have my doubts. I have my severe doubts. What value is when? I need a calibrated thing. How can I calibrate this piece of code when this value is not consistent? Nice idea, but I have my doubts. Right, I have let everything run for a bit, and to my surprise the value changes once again. Now it's towards 700 and then 650 and here again. So now looking at this value of the phototransistor, and I've checked again if I haven't accidentally put it in on a different connection, but no. This is one cell. One cell is now set to 1 volt. So it's a low voltage. And it doesn't change the voltage. It just goes up. And when I hold that leaflet, then it just stays some value. And that doesn't match with these values of the phototransistor. Now it's gone back to 650, but it's not anything close to 5 something, 599, 597, whatever. Then coming back to the NTC, which was 36 for a while, now it's gone to 20, 25, 27. So the phototransistor is not the only element that gives, in the same circumstances, a very different value for when nothing happens actually. So let me take the NTC again and hold it right here. Maybe more appropriate here, really into the lamp. What happens? Well, this is kind of an interesting idea, because when it now touches the lamp, you can see its value change. 54 to close to 100 and over 100. So that seems to make a difference. And now look at the phototransistor. Is there anything to be said about coincidental or whatever? 690 for a very low NTC value. 645, even lower value for the NTC. Now these are just values, these are not... Oh, where does this go? Oh, it's out of the NTC. That is not the intention, clearly. And I do have a screwdriver here. Alright, back in. Anyway, I realize that those values are not real value, the values of the NTC are not temperatures. So I still need some formula to calculate that. However, I want it to stabilize, and as yet I do not know how. So how to get on with this? Not really sure. Not really sure. Yeah. Have to put my mind to this. Let's see, phototransistor, which is right there, is also just a value for now. Standing still, but it should affect this one. Barely visible. And you can see how it is influenced, but that is also dependent on how this lamp is shining on it. This is better, although slightly better. Yeah, how to go on? Good question. Last segment for this episode. So what did I do? Recap, apart from keeping this mechatronics going. Using a leaflet and putting it in here doesn't give much optimism. With this LED, which should give lower value, so shine less brightly whenever it's being covered from here or addressed from there. It doesn't work yet because of some very inconsistent values from the transistor. How and why, I can't tell yet. Some code changes. An NTC that is still not really working as I like. I can put it right onto the lamp and then it gives some value, but the original experiment from what I took it with the propeller is that it shines with 9 volts, but as I told in the beginning, this gives 5 volts and I don't have a power source with 9 volts. I would blow up the board, but if I keep things separated it could be possible, but then I would not be able to address the lamp by software, and that is much nicer, and I would be able to do some more things. So I I prefer to keep things the way they are now. Nicely running, but with some questions. Oh, what I just realized, I have this probe, which is the lowest line on the oscilloscope, and that gives barely a value as well. So let me go there for a moment. So I'm talking about this line, and if I select this one and I change the value to 1 volt, this is what is measured. And look at the lowest line on the oscilloscope. So yes, the resistance definitely changes. And that's a good thing. And with that I come back to the rest of the board. And well, thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up and leave a comment. You can also follow me on Instagram. Please like and leave a comment. You can also follow me on Twitter. Please retweet, like and leave a comment. Please donate to keep videos coming to you. You can also become a patron and have your name mentioned. And this is certainly going to be continued. So for now, thanks for watching. Bye bye.